For a CCNP level role, technical expertise is your entry ticket, but your communication structure is what actually secures the offer. Many candidates spend hundreds of hours memorizing isolated definitions, assuming that simply knowing the theory is enough to pass. But without a plan for delivery, that knowledge often comes out as a rambling, jargon-heavy answer that fails to make an impact on the hiring manager. Regurgitating a technical manual proves you can study, but it doesn't demonstrate that you know how to apply those concepts in a high-stakes enterprise environment. To bridge that gap, we need to aim for a specific target, balancing deep technical knowledge with a highly structured delivery. If we map this out, your technical depth is on the x-axis and your communication style is on the y. To reach the higher zone, you have to land in this top right quadrant. The most effective tool to get you there is a three-part protocol: definition, example, and use case. This framework forces you to move beyond abstract theory and speak the language of a senior engineer, connecting technical features directly to tangible business value. Let's apply this to BGP. Your definition should be concise. BGP is a path vector routing protocol used to exchange routes between autonomous systems. Because it's a path vector protocol, BGP tracks the full sequence of autonomous systems required to reach a specific destination. Keeping that full path information is what allows the protocol to prevent routing loops and select the most efficient path. For the example, you can point to route policies, like manually adjusting the local pref attribute to force traffic through a specific gateway. This leads to the ultimate use case: granular traffic engineering. It gives a business the power to choose one ISP over another based on cost or performance. EIGRP offers a different focus. It's an advanced distance vector protocol using the dual algorithm to prioritize rapid convergence. The example is the feasible successor, a pre-calculated backup route satisfying the feasibility condition where advertised distance is less than feasible distance. Having that backup ready means the router can fail over instantly without needing to pause and wait for the network to recalculate. You can also use variance as a second example of EIGRP's flexibility. By setting the variance multiplier, the network can perform unequal cost load balancing, sending traffic across both primary and backup links simultaneously based on their respective speeds. In an interview, the EIGRP use case is showing how you ensure high availability and maximize the use of all available bandwidth. Moving to Layer 2, the primary architectural challenge is managing the risk of broadcast loops that can take down a switched network. By definition, Spanning Tree Protocol, or STP, prevents these loops by electing a root bridge and blocking redundant paths. To manage that traffic, you have to distinguish your ports. Access ports are for single-end devices, while trunk ports allow multiple VLANs to travel across a single physical link between switches. Standard STP's flaw is that blocking a trunk port stops a loop, but kills the connection for every VLAN on that link. Example solution: PVST+. Running separate STP instances per VLAN lets you block one group while keeping another open. This creates a use case for Layer 2 load balancing, where you use your redundant links effectively instead of just leaving them idle. Finally, scaling a network requires managing services across different subnets, particularly when it comes to IP allocation. A DHCP relay is defined by its ability to forward local broadcast requests to a centralized server on a different network, usually via the IP helper address command. The relay agent adds a GIADR, a gateway IP, so the server knows exactly which subnet the client is on and can assign the correct address. To keep the routing table manageable at this scale, we use route summarization, the practice of combining multiple specific routes into one aggregate prefix. Even with these summaries in place, the longest prefix match rule ensures that the router will always pick the most specific available path for any given packet. Master these concepts, and your use case is clear. You can optimize enterprise-scale performance and reduce administrative overhead. When you distill these protocols, the associations become clear: BGP for policy, EIGRP for speed and variance, STP for loop prevention, and trunks for multi-VLAN transport. For junior engineers, focusing on the use case prevents you from sounding like you're just reciting a textbook. It makes you sound like someone who has actually managed a network. For veterans, the strict definition and example format keeps your answers tight, ensuring you hit every technical requirement without getting lost in the weeds. Let's test how this structure feels in practice. Take these 3 prompts. Try to answer them right now using the 3-part framework: definition, example, use case, without looking at your notes. In a senior-level interview, your knowledge gets you the meeting, but your structure is what gets you hired.